Okay, class, so here's our lesson on 2.3. So in chapter 2, we've been solving equations. You had some of those equations to solve on your test. This section is titled Applications of Linear Equations. In other words, what are some kind of word problems? Forgot a letter there. I just totally messed up that word, didn't I? Applications there. Applications mean what are some word type problems we could use these linear equations that we've been studying to solve. So many times I hear students say, I can do the math, I just hate the word problems. And you know what, if you have struggled with word problems, that just makes you a normal human being. Everybody struggles with word problems. So just get in line with the rest of us. Okay, that's just par for the course. But they are gettable if you practice them enough. A lot of times, students just don't know where to start on a word problem. So our real challenge here is to get what looks like a problem in words into a problem that looks like a math problem. Once it's a math problem, you know how to do the math. So you're okay with that. So in this section, I'm going to teach you a process by which you can approach just about any word problem with. And this really is kind of the process of algebra. You see this process in one form or another in just about every algebra book. Now, are you going to have to use this process on every problem? No, you wouldn't have to. Some problems can be worked without using this process. But eventually you're going to run into a problem where you don't know where to start. And you're going to need something to go to. And that's where this process comes in. So we're going to use this process on all our problems so that we can kind of become familiar with it so that it's there when we need it. So I just call this a four-step process for problem solving. Okay, so this is the way we're going to approach our word problems today. Step one, we're going to do something called define a variable. What does that mean to do? Well, that means we're going to pick a variable, x, y, z, whatever, and we're going to tell what it's equal to in the problem. So we're actually going to write on our paper, x equals. Now listen, 9 times out of 10, it's going to be best to let x be equal to whatever we are asked to find. If the problem says, what's the distance from the Earth to the Moon? We're going to let x be the distance from the Earth to the Moon. If the problem says, what's the price of a Snickers bar? We'll let x be the price of a Snickers bar. So we're actually starting at the end. We're starting with the question. Okay? Now, once we define x, then what we're going to do is try to write an equation with the x. What does that mean, Mr. Black? Well, we're just going to try to write an equation with x in it. Why? Because if we've got an equation with x in it, then we can solve that equation for x. And if we solve for x, we really will have solved for whatever we were asked to find. So then, once we've got an equation for x, then third, whoa, what happened to my pen color there? Let's go back. Then third, we'll solve for x. And then fourth, we'll give a check. Okay, now think about step 3. We're going to solve for x. If we solve for x, then really what we'll have is what the problem asks for. So that's really the idea. Now as far as a check, we don't need some big written formal thing. Basically we're asking 2 questions. Is the answer reasonable? For example, if the problem said, how many siblings does Mr. Black have? and you got x equals 2.4, something's not right because that's not reasonable. And then the second thing we're going to look at is, did we answer everything? So if the problem asks me, say, for two things, how old is Mr. Black and how old is his brother, and we put x equals 4, that's probably not the answer to both of those things. Might be the answer to one of them, but not both. So we've got to make sure that we answer everything that we're asked to find. Well, let's look at a couple of example problems from your textbook. And we're going to begin on page 69 and look at example 3 off of that page. If you need to pause here while you get your book, you can do that. And it reads like this: the length of a rectangle is 1 centimeter more than twice the width. The perimeter of the rectangle is 110 centimeters. Find the length and the width of the rectangle. Okay, so let's run through our 4 steps. Step 1 was to define a variable. So we're going to let x be whatever the problem asks me to find. As I reread this problem, at the very end, and that's where you usually find what you're asked to find, is at the end, we're asked to find the length and the width. So we're actually asked to find two things here. So we're going to let one of those be x. Which one, Mr. Black? Well, it doesn't really matter, but one's going to be easier than the other. We could let x be either one of these and get to our solution, but one's going to be easier than the other. So here's what a former student of mine came up with, and I thought, that's really good. I'm going to tell all my students that. They said it this way: it's usually best to let x be equal to the thing that you know the least about. Do I know less about the length, or do I know less about the width? Well, I don't remember. I'm going to have to reread the problem and see. So rereading the problem says the length of a rectangle is 1 centimeter more than twice the width. So the one I know nothing about is the width. So I'm going to let x be the width. Now, since I'm looking for the length, I still need something for that. Okay, so what does it say about the length? It's 1 more than twice the width. Well, if the width is x, then twice the width would be 2x, and 1 more than that is going to be 2x plus 1. Okay, so step 1 is done. We've defined a variable. Now, step 2, let's write an equation. So here I have to ask myself, what is it that I was given in the problem that's going to allow me to write an equation? So let's reread the problem and see what little piece of information they gave me. The length of a rectangle is 1 centimeter more than twice the width. The perimeter of the rectangle is 110 centimeters. So look, if it's a geometry problem like this one, it's got a rectangle involved, a lot of times drawing a picture is a good idea. And so if I call this the width, we know that that's x. And so over here, this would be the length, so that's 2x plus 1. We're told that the perimeter is 110. So the question is, do you remember what the perimeter of a rectangle is? Well, perimeter means around the outside. It means what this distance is from here, down to here, over to here, and up to there. So all the way around the rectangle. That's the perimeter. So if you think about all the way around the rectangle, we would have this x plus this 2x plus 1 plus another x down here that's going to be x as well, plus, and then this side over here is also going to be 2x plus 1. So when I add up all four sides of that rectangle, I've got x plus 2x plus 1, plus another x plus another 2x plus 1, and that equals the perimeter of 110. Okay, now class, do you see that we've changed this problem from a word problem to a math problem, to an algebra problem? Listen, that's the hard part, is the reading. The hard part is getting it into a math problem. You know how to do the math. You know how to solve this equation. Let's combine our x's. X and 2x is 3x, and x is 4x, and 2x is 6x, plus 1 and 1 is 2, is equal to 110. We're going to get the x by itself, so I'm going to subtract 2 from both sides. So 6x is equal to 108. And if we divide both sides by 6, if I divide 108 by 6, I'm going to get x equal to 18. And by the way, since we're in Chapter 2 now, you can use your calculator to help you do that division. It's fair game. Alright, so we just did step 3. We solved our equation. Now, step 4 is, let's do a check. Okay? Is the answer reasonable, and did we answer everything? Well, we haven't answered everything because we've got x equal to 18. X we define to be the width. So I know the width of our rectangle is 18. The length, then, if we think about that, that's 2x plus 1. So now that's going to be 2 times, we know x to be 18 plus 1. Or 36 plus 1, or 37. So, what are the dimensions of the rectangle? They're 18 by 37. Now listen, that's a fairly involved problem. You could see one of those on your next test, but most people are not awesome at these the first time they try them. So you got to try your homework, see what you have trouble with, make sure you ask questions the next day in class, go back and try them again. A lot of times that second time through is when it'll click, but maybe not even then. You may have to ask 3 or 4 times. But most students, if they'll stick with these, they'll eventually get them. Okay, so what I'm trying to say to you is don't get discouraged if there are some homework problems you struggle with on this assignment the first time you try it. That's just part of doing word problems. So let's practice a little bit more. So I'm looking at example 4 now on page 70. So it says, during the 2009 regular season, Justin Verlander of the Detroit Tigers and Tim Lincecum of the San Francisco Giants were the top major league pitchers in strikeouts. The two pitchers had a total of 530 strikeouts. Verlander had 8 more strikeouts than Lincecum. How many strikeouts did each pitcher have? Well, again, that's a lot to think about. It's a lot of information. So we don't want to try to think about it all at once. Let's just start with step 1. Let's define a variable. We'll let x be equal to what we're asked to find. So the question here is, how many strikeouts did each pitcher have? So I'm looking for 2 things again. So I need something for Lincecum and something for Verlander. We'll let x be the one that we know the least about. I don't remember which one I know the least about. I'm going to have to reread the problem again. So multiple readings is important here. To my classes, I usually say this. The problem with word problems is not math. The problem with word problems is reading. The hard part is the reading. So let's read again, see which one we know less about. During the 2009 regular season, Justin Verlander of the Detroit Tigers and Tim Lincecum of the San Francisco Giants were the top Major League pitchers in strikeouts. The two pitchers had a total of 530 strikeouts. Verlander had 8 more strikeouts than Lincecum. So which one do we know nothing about? We know nothing about the number of strikeouts for Lincecum, so we'll let that be X. And we know Verlander had 8 more, so he would have had X plus 8. Okay, step 1 is done. We define variable. Step 2, let's look for information in the problem that will allow me to write an equation. Okay, so what do we know? It says the pitchers had a total of 530 strikeouts. So if I add their strikeouts together, it has to equal 530. So what am I adding together? Well, Lincecum struck out X and Verlander struck out X plus 8. So I need to add those two together to get the total. And if you add X to X plus 8, you can combine those X's. So together they struck out 2X plus 8. The X for Lincecum plus the X plus 8 for Verlander. Okay, step 2 is done. We've got an equation now. Let's solve the equation. So we can subtract 8 from both sides. Again, now this is a math problem now, so it's pretty simple. We know how to do the algebra. So 2x is equal to 522. Divide both sides by 2. If you want to use your calculator to divide 522 by 2, you can. It should turn out to be 261. Okay, well, have I answered everything I'm supposed to have in the problem? No! I've only answered how many Lincecum had. He was X. So Lincecum struck out 261. So Verlander would have struck out X plus 8. That's 261 plus 8 is 269. Okay, so listen, this is the first part of this lesson. The second part of the lesson is on the next video that I posted. Now you can skip the first part of that video. You're going to want to go to the 10-minute and 35-second mark and pick up there when the video starts talking about mixture problems. And those are really, really challenging. So you want to pay extra close attention to that and take good notes. So go and watch that video now, and I'll email you what the assignment is.